All right, so as I already posted on my webpage, we're gonna do next week, the last week of the finals, the final week, so to speak. We're gonna do 2 quizzes, big quizzes, and so there will be several questions, 4 questions, and you have more time also, 3 hours. Go look at the webpage to see all the details here. And so I'm splitting material in 2 parts, namely the part that we did face-to-face in the beginning of the semester. There was chapters 1 and 3. That will be the first quiz, big quiz 1. And so let's focus on that one now. Now, before I start, I want to remind you, so when you submit the answers, there are a couple of things you can do. One thing you have to be, we're going to do it by email, and these files might get really big because instead of 1 question, now you have 4 questions, right? So if you see that your file is getting too big, I give you, there's also on my webpage a link, a little video on how you can reduce the size of an attachment. Now, I myself use an iPad, so I know how to do it there, but if you have a different platform, you have to find out yourself how it works. So that's one way of doing it. Another way is, so it's either reduce the size. For instance, there are, some of you I saw making PDFs of it. That is definitely something you should try to do, because this online teaching is going to continue, and many instructors actually request that everything is put in a PDF file. I didn't do this, but so it's something you might want to learn how to do. So reduce the size, or submit various questions separately. So submit questions separately. You are allowed to do that. So you can send me 1 or 2 or 3 emails to reduce the size of each email. I would keep them under 10 megabyte, because I'm afraid that if you do higher than that, the email system might slow down. It might take, I might not get the email on time, and then I might think, yeah, you're going over time. Okay, I know there have been hiccups with email, and I will be a little bit flexible about that. But so try to reduce the size of your questions. Another thing, I would actually even encourage a little bit to do these separate submissions, especially when you're running out of time. The ones that you're kind of certain of and have done, already submit them, that they're out of your hair, so to speak. That way, what I wouldn't want to happen is that all of a sudden you realize, oh, I have no time anymore, and I cannot, and then you start panicking and you take pictures of the wrong things and you forget what you're doing. So manage your time a little bit. Make sure that you don't run out of time, and that you can submit everything. And remember, what you have to submit is, in your answers, all work. If you give me an answer without any justification, without any calculation, I will not give points for that. I told you the work is more important than the results, than the final answers. Okay? Okay, so that about the logistics of the question, the day itself. Now, what about the content? So chapters 1 and 3. So this is a lot of this has been covered already in midterm 1. So I'm going to quickly go overview of some of the questions in midterm 1. Not all of them are so relevant. So the first one, of course, is calculating an angle. Okay, and so I remind you that this is given by this formula here. You have this formula. Sorry. Let me go get the formula here. So we use that the theta is the arc cosine, and then you have to calculate this number here, and as you take the product, the dot product of the 2 vectors, and then you divide by their norms. So this is the quantity you calculate, and with that you take the arc cosine in radians or in degrees, doesn't matter, and that gives you the angle. So that's how you answer this question. Now, how do you get these vectors u and v? Now, remember, these a and b are points, and so if u is the vector a, b, that means that what you have to do is you take the coordinates of B and subtract the coordinates of A, in that order. Okay, that's how you find U, and the same for B. The solutions of this midterm are also posted, so I'm not going to give them here now. So go look at those solutions, how the actual answer works. Okay, that's for the first question. So this relies on the dot product. Orthogonality also relies on the dot product. Here is a question where, so very often these questions I'm going to ask, so where you have to find a certain t that makes something orthogonal or gives you some value that you want. Okay? And then we also have talked about the projection of U onto A. That's a formula. Please go look it up. Now, these questions 4 and 5 are not, we've done so many of these things, so I'm not going to talk about these now. And then, of course, what we have is solving system of linear equations. Now, we have done this quite a lot, okay? And even, especially in the second part, we constantly are doing this, right? So it's not that this is just belongs to this particular part, right? But it is something here. So I want to give now a little bit other questions than the ones that I just lined out, and give a little more examples. So let me see here. The first thing I wanted to do is, so here is an example of some extra, so more questions. So for instance, about a question here, okay, so we have 2 points in R4, 1, 2, 1, 5, and A is the point 0, minus 1, 1, 1. So this is in 4-dimensional space, okay? And moreover, I have 2 vectors. U is the vector, again, I'm going to write the vectors as this way, 8, 0, 1, 2, and V is the vector 0, 0, 3, 1. The reason that I give it's a lot of information, but I want you to make sure that you know how to combine things. And the question is this: find t, well, which t? I'll explain where the t comes from, such that the vector AB is orthogonal, let me write it this way, to the vector U plus t times V. No, t times V. So t is a number, a real number. So it's a real number, right? So, but we have to find the t such that this vector is orthogonal to this vector. So it's a bit making sure that you know all the different representations of vectors and how you calculate these things. So let me give you the solution of this. So first of all, we have to find the coordinates of AB. Right? I told you it's the coordinate of the last point, and subtract from that the coordinates of the first point. So the coordinates of this vector now. So notice that we use both tuples to denote vectors as well. So this is a vector and this is a point. It's not clear from the right hand side what we mean, but that's the ambiguity that we allowed. Okay, so what is the coordinates of this vector AB now? Well, that is 1, 2 minus 1, that is 3, 1 minus 1 is 0, and 5 minus 1 is 4. Okay, now what is this vector? Well, that is 8, 0, 1, 2 plus t times, I'll write it here, plus t times the vector 0, 0, 3, 1. So that is the vector 8 plus t times 0, 0 plus t times 0, 1 plus 3 times t, there you go, 1 plus 3 times t, and then 2 plus t. Okay, so now the question, how does orthogonality means that we have to write, the condition is that the dot product of these 2 vectors that I now just calculated in 2 different, that this is 0. Okay, that is what orthogonal means. So we have to work out what this means, and it is product of each of the entries, corresponding entries, and then add everything up. So 1 times 8 plus 3 times 0 plus 0 times 1 plus 3 plus 4 times 2 plus t is 0. So we get 8 plus 4t equals 0. That means 16 minus plus 4t equals 0, so that means that 16 is negative 4t, or that t is negative 4. Okay, something like that. Okay, so that's not hard, right? Another example of this nature is, so find t, again, a number, such that the norm of the vector u is equal to 3, where u is the vector 1, t, 2, 0. Okay, so, well, let's calculate the norm of this vector. What's the norm of u? That's the square root, don't forget there's a square root, of the squares of the coordinates. So 1 plus t square plus 2 square plus 0. So square root of t square plus 5. And now we have to put this equal to 3, and so we have to solve this equation. Now, how do you solve an equation like that? We isolate radical, which is done, and then we square both sides, right? So we get t squared plus 5 equals 9. So this is squaring both sides. And then we solve t squared equals 4, so we see that t is plus or minus 2. Notice there are two solutions because there are a positive and a negative square root. So this can be, right? So some of these problems can have several t for which this is true. Okay, so that's an example of a problem like that. Another one is that was not on the midterm, but like another question that was not on the midterm, but it belongs to this chapter also, is what's the equation of a plane that is orthogonal, or normal, one sometimes says, to the vector u with coordinates 1, 3, negative 1, and and going through the point or containing the point 4, 0, 1. Okay, so there are a couple of ways of doing that. One way is saying, okay, so we think of this, we make a general point on this plane will be of this form, and so that's, sorry, yes, yeah, okay, sorry. I don't want to spend too much time explaining it because you should go look it up here, but we take a point with coordinates x1, x2, x2, x3, so this is supposed to be a general point on this plane. So now, what's the vector? So a vector that is determined by this point and this point is the vector x1 minus 4, x2 minus 0, x3 minus 1. Okay, so this is the vector given by the point that we have fixed and the point that's on the plane, and this has to be now orthogonal to this vector. So this is the condition now, 1, 3, minus 1. We can work this out. This means x1 minus 4 times 1 plus 3 times x2 minus 1 times x3 minus 1 equals 0. And that's the equation. We can solve this. X1 minus 4 plus 3x2 minus x3 plus 1 equals 0. And then normally we write an equation in this form, right? We put the constant on the other side. That would be plus 4 minus 1, so a 3 here. Alternatively, you can also say, so alternatively, we can do this much quicker, saying, okay, if this is the what we call the normal vector, we know that these are the coefficients of the x1, x3, x2, and x3. So the coefficients are 1, 3, and negative 1. Those are these coefficients equal to 0. Now, this is the equation of, okay, let's be simplified. This is right, x1 plus 3 times x2 minus x3 equals 0. This is the equation of a plane that is perpendicular to this vector u and that goes through the origin. Now that's not what we want. We want a plane that goes to this point. It might be that this goes to this point, but how we do this? Well, we know that if you're perpendicular to something, then anything that is parallel to this plane is also going to be perpendicular. And what are the parallel? So a plane that is parallel, any other plane that is parallel is of the form t for some t. And if for any t you get a plane that is parallel to the original plane, and these are exactly all the planes that are parallel to the original plane. Okay, so now we have to just find t such that the point 401 lies on it. So now we want the condition that 401 is on this plane, right? That means for the plane to go through it. So we plug in these coordinates, 4 plus 3 times 0 minus 1 equals t, and we see that t equals 3. And then we recover the original problem. So that's two ways of doing it. Look at the notes to see where this comes from. All these practice, if you want to practice more of these problems, go to the homeworks, look for similar questions like that. Okay. Another one that I want to talk about is something that we have done is systems of equations. But I will ask you it in a bit more special form like this. Here's an example of how I want to do it. Find t, again, find t such that the following system of equations is solvable. Is solvable. And perhaps I also and find all solutions, and then find all solutions. Okay, so here's an example that I have in mind. So here's the system of equations: 2x1 plus x2 plus x3 equals 3. x1 minus x2 plus 2 times x3 equals t is a number variable here. T, and then x1 plus 2 times x2 minus x3 equals 1. So how do you solve this? So remember, what you do is, first of all, you make the matrix of this system of coefficients, the system of equations. Those are just the coefficients of the variables. Okay, and then you have the column of the constants. Okay, so let's row reduce until we have reduced echelon form on the left hand side. And once we have that, we can see what happened. So I'll work it out, and you'll see better what is going on. Well, first of all, I don't want to introduce too many fractions, so I'm going to switch row 1 and row 2. So that is 1, negative 1, 2, t, 2, 1, 1, 3, 1, 2, minus 1, 1. Okay, just don't forget that this is augmented column, the extra column that we have there, right? And so, okay, we have now our pivot, this one, and we're going to use this to get row 2 minus 2 times row 1, and row 3 minus row 1. Okay, so that is 1 minus 1, 2, t. So we do this minus 2 and get a 0 there. 2 plus 1 is 3, minus 4 plus 1 is negative 3. And then we have 3 minus 2 times t. And now we do with negative 1 and add to the next one. That's a 0. Negative 1 is 1 plus 2 is 3. Negative 2 plus negative 1 is negative 3. And then get 1 minus t. Okay. Well, we need a 1 here, so we have to divide by 3 in one of these two rows. Let's do the row 2. 1/3 row 2. Okay, sometimes fractions are inevitable. I mean, luckily the fraction is only in the last column, so get 1 minus 1, 2, t, 0, 1, minus 1. This divided by t is 1 minus 2t over 3, okay? And then 0, 3, minus 3, 1 minus t. I can use this pivot now, so row 3 minus 3 times row 2. Multiplying this row with negative 3 and add up to this row. So it is, okay, let's copy the first one first. and then the last one is 0. So minus 3, but that is 0. Minus minus is plus 3, minus 3, oh, that's also 0. And then we get here, well, let it write it up, right? It's 1 minus t minus 3 times 1 minus 2t over 3. So let's work this out. It's 1 minus t, and this put negative 3, and that is then plus 6 divided by 3, so plus 2t. And so I can combine this as that is negative 2 plus t, right? 1 minus 2, yep. Okay, so let me write it up one more time. What we have, 1 minus 1, 2 t, 0, 1, negative 1, 1 minus 2t over 3, and then 0, 0, 0, t minus 2. Okay, let's look at what we have here. We have two pivots here. And so if this would have been a homogeneous system of equations, we'd have one free variable. But there is another pivot, or potentially a pivot. This could be a pivot, right? If you look at the whole matrix, everything. This is not allowed, because that would mean 0 times x1 plus 0 times x2 plus 0 times x3 is equal to some non-zero number. So this is the condition. This has to be 0. Remember, we can never have a pivot in the augmented column. That's the condition for solvability. So it all comes down to what number you get here, that should be 0. So we see that t is 2. So that answers for which t. Find t such that the following is system equation solvable. Now, if they also ask, well, what is it then? Well, let's write it down. So now we put t equals 2 in there, right? So we get 2 here, and then 0, 1, minus 1, and we get 1 minus 4/3. That is minus 1/3, right? All right, and so we have to get, to solve a system of equations, we always want to be in reduced form, and this is the one thing that is not reduced yet, because we have these two pivots, right? So these are the pivots, but we need something above there, okay? So we do row 1 plus row 2. We get 1, 0, 1, and now I have to add 2 minus 1/3, that's 6/3, 5/3, and then I have 0, 1, negative 1 minus 1/3. So one more time, x1, x2 are the pivot variables, x3 is a free variable, and so now we write down whatever we have, x1, x2, x3. Now, lately we have been doing the column, eigenspaces and null spaces, which is always for homogeneous system equations. These are non-homogeneous system equations, so we have to keep that in mind, right? So this first equation says, what it means is 1 times x1 plus 1 times x3 is equal to 5/3. So if we solve for x1 in terms of x3, that's what we get, right? So we have now these constants also coming in. And the next one is minus 1/3 plus x3. And of course, x3 is still x3. That always stays, right? The free variable is equal to itself. So now we have to separate the terms that have x3 in it and the terms that don't. So there's the 5/3, minus 1/3, and 0. That these have no x3, the 0 because there's nothing in the last one, right? And then the ones that have an x3 in it is minus 1, 1, 1. Okay. So for this is now the general solution of the system of equations. No matter what, for whatever value of x3 I take, I get a solution. Okay. All right. So that's the question on solving linear statistical equations. But I'm going to do something like that to make it a little bit more. We have done so many systems of equations. I want to have a little bit more, different type of question on this. Okay, and then finally, the last topic that we also covered before we went online was finding the inverse of a matrix using row reduction. Later on but that was already during the online portion, we found the method we discussed the method of the adjoint, but I want to do this, I'm asking you to do it here with row reduction. Okay. Now I want to show you that you have to, in this kind of questions, when it's about inverse of matrices, again, go look at homeworks and other places for more problems and so on, but I'm just going to do one here. So here's my matrix, 1, 3, 0, 4, 0, 2, 0, negative 2, 5, 1, 2, 2, 0, 4, 0, 1. And what I wanted to show you is that in this when it comes to inverse of matrices, it's hard to not have fractions. You'll see, fractions will happen. So the way to do this is, of course, we now, instead of one column, we have the whole identity matrix as at the augmented part. And now it's just a matter of, some people forget to put this here, right? And they start reducing this matrix, and then they get the identity matrix. Okay, what you have then proved is that the matrix is invertible, but you haven't found the inverse. That's why you have to, that's what happens in the second part here. Okay, so I made it so there's not too many things that you have to do. So first we have this pivot already, so row 3 is row 3 minus 5 times row 1. So we get 1, 3, 0, 4, 1, 0, 0, 0, 0, 2, 0, negative 2, 0, 1, 0, 0. And so negative 5 and I add up, so this is 0. Negative 15 plus 1 is negative 14. That's 0 plus 2, and then negative 20 plus 2 is negative 18. Now, don't forget there's a 1 here also. We get a negative 5 here. And then, no, 0, and then a 1, and then a 0. Okay, this one we just copy. Okay, but now we need the next pivot, and you see that we have a bit of choices here, but each of them we're going to have to create a fraction. The first, as it stands, it's best to work with row 2, right? Because at least there's no fractions. There's only going to be one fraction then. So row 2, a half row 2. Okay. So a half here, and all the rest stays the same. Oh, that's 0, negative 14, 2, negative 18, negative 5, 0, 1, 0, 0, 4, 0, 1, 0, 0, 0, 1. Okay. Next is using this pivot to get the two numbers on beneath it, 0. So row 3 plus 14 times row 2, and row 4 minus 4 times row 2. The first two rows, nothing changes, so we just copy. Okay, so now we multiply this with 14 and add up to this row. So we get 0, 0, 2, minus 14 minus 18 is minus 32. Then we add 0 times negative 5. Then 14 times, adding, right? Yeah, so 7, 1, 0. Then we have, now we do, oh, it does this sometimes, huh? I hope I didn't lose anything here. No, you gotta be kidding me, I lost everything.